Today we'll be reviewing Unit 8, Lesson 3. The first part of the lesson deals with bearing. Bearing is a method of giving directions. Bearing always includes two cardinal directions and an angle. What's key is the fact that whatever our point of reference is, we're going to pretend like it's the origin in the coordinate plane. We're first going to move in one direction and then open our angle either to the left or to the right. So if we look at our first drawing, we're asked to draw north 55 degrees west. Starting at the origin, one side of our angle is going to be drawn due north. We then, as I said, can open left or right. We're going to open to the left because that would move us into a western direction. The angle that is formed between these two sides is 55 degrees. Following suit in our second example, south 67 degrees east, we're going to move south and then open to the right in an east direction of 67 degrees. It's the central angle located at the origin. In our next examples, I'd like you to try drawing north 45 degrees east and south 15 degrees west. Please pause the video at this time, then move forward once you've tried drawing them on your own. As you can see in our first example, due north, opening to the east, the measure of the central angle located at the origin is 45 degrees. In our second example, we're starting in a south direction for one side, opening to the west, and the measure of theta, which is the central angle, is 15 degrees. Take a moment to read example 1, pausing the video. Word problems become increasingly easier once you understand how to continually draw the drawings correctly. There's some information that's understood that we're going to review in this word problem. This should be the correct diagram for the picture for this word problem. Fire Ranger A sights a fire due south. However, when we move to the second sentence, there's a question, because second ranger is at point B. Is that in reference to the east of the fire or the first fire ranger? Whenever we're given information, we always want to refer back to the subject of the previous sentence. So when it says 7.5 miles east, that would be east of Fire Ranger A. So B is located due east of Fire Ranger A. Now, you may think that the origin would be located at point A, but when we are given bearing, the bearing is the direction from a specific place. That place is going to be the new quote-unquote origin of our picture. So this point B that we have in our diagram is the origin. We want to look south and then we want to open to the west to draw our angle. This may not be something that you would think to do because notice we've just now created an angle outside of the major triangle. However, we know enough from geometry to figure this out. We have two different options. At point B, we need to recognize that we have a right angle. We could use complementary angles and subtract from 90 degrees to find the inside angle. However, if you notice, the line of sight from A to the fire and B's line of sight due south are parallel lines. They are cut by a transversal, which I'm highlighting now. You should have learned in geometry class that if two parallel lines are cut by a transversal, then the opposite interior angles are equal. This means that the interior angle of the major triangle drawn, located at the fire, is also 27 degrees 23 minutes. From here, if we use that information with our right triangle, we can set up an equation to solve. Tangent of 27 degrees 23 minutes is equal to 7.5 over x. In the drawing, you may have labeled it b. However, we're trying to find the distance from A to the fire. Solving this simple trig equation, we come up with 14.48 miles. Take a second to pause the video and read example 2. If you've never been to a baseball park and you have little knowledge of the game of baseball, this problem might be increasingly difficult for you. So allow me to explain the basic setup. You are located in a seat in the upper deck. If we come straight down, which probably will run through other fan seats, that's going to bring us to a right angle. The first key landmark is going to be the home plate. The second is the pitcher's mound. Now, what you may not know from the given information is that the distance between those are 60.5 feet. That is the distance between home plate and the pitcher's mound of a standard baseball field. Now, what we are asked to find is the viewing distance from our seat. So when we look at this drawing, okay, keeping in mind that this is your line of sight at level, think about the angle of depression notes that we've done earlier. We actually have two different triangles. We have the inner triangle, which represents you and your eye distance to home plate, and then we have the little bit bigger triangle, which involves you and your viewing distance to the pitcher's mound. Please remember, 29.9, 24.2. 29.9, you're dropping your eyes much further. By dropping your eyes further, you're looking at an object that's closer to you, home plate. Again, opposite interior angles or angle of depression is the same as the angle of elevation. Same thing is true with 24.2 and 24.2. Now, 60.5 is the distance between the mound. In both of these drawings, we have D. However, we need to add the 60.5 to D to talk about the distance, the ground distance to the actual pitcher's mound. H is the same in both, it's your height, giving us two separate triangles to work with. If we look at these same two triangles, we can set up two equations. This is the part that's new, and it's going to require a lot of work, and yes, you're going to have to do a problem like this on your test. First thing, relating 29.9, H, and D, we can do that using a tangent equation. I'm then going to solve for H. In the second triangle, I'm going to do the same thing. I'm going to relate the 24.2 to H, but rather than simply D, I have a quantity, 60.5 plus D. Notice I'm going to solve for H by multiplying both sides by the denominator, and then I'm going to distribute. Don't go to decimals at this point. Don't put this into your calculator. Leave it as is. So if it says tangent of 24.2, while yes, that does come out to a decimal, we don't want to round our decimals at this point. Effectively, we're going to solve both equations for the variable H, because the height in both of these triangles is the same. So that's going to be our common variable. The height of the left is equal to the height of the right. So using substitution, we can take this H on the left out and replace it with what we've solved for. And using this H of the right, we can replace it with this expression. You can see that in step 1, which the arrow is now resting next to. From there, we need to solve the equation. We've done this numerous times this year. Put all of the D terms on one side. Secondly, factor out the D times a quantity. Our last step then is to divide by the quantity. If you do that correctly, you should get 216.47. Please take a minute to pull out your calculator and put this in to verify that you can get the correct answer. Now, unfortunately, we weren't asked to solve for D. We were asked to find the viewing distances. The viewing distances would be to home plate and then also the viewing distance to the pitcher's mound. So our last step is to set up two more trig equations. In this case, we know the angles, but we don't know the hypotenuse. So since we can figure out what the bottoms are of each of these two triangles through simple substitution, we can solve for x and we can solve for y. Your homework is number 56, page 337. There are a handful of problems like the last example. Please model off of what you've done. Don't say you can't do it because you absolutely can. Good luck.